Hi, kids. All right. You did a lab, convex lens lab, and I'm not there to go over it, so I'm here to go over it. So let's talk a little bit about the lab. You should have had a setup that looks like about and you have an object, and just remember that everything was always measured to the center of the lens. So, you got your SO and your SI and your little upside down candle and everything. And then you're supposed to collect a whole bunch of that data and then make a graph, and hopefully your graphs look something like this. Okay. And then you were supposed to draw a best fit line. So I'm going to draw a best fit line. I don't have a ruler here, so I'll just do the best I can. You, of course, used a ruler. So you would have something that looks like this. And then you were supposed to use this and interpret this. Well, if you think about the equation of a line, so let me write down the equation of a line. Y equals mx plus b. Okay. Well, what is y? Y is really 1 over si. What is x? That is 1 over so. And what is b? Well, I don't know what b is, but your slope should have been -1. So you should have had something that looks like this. Okay. So there, again, all I'm using is y equals mx plus b, and I'm just plugging stuff in that I knew. And again, your slope should have been -1. Well, if I rearrange this equation, hey, look, lo and behold, I end up with the optics equation, which is 1 over si plus 1 over so equals 1 over f. Well, that means that the y-intercept is 1 over s, 1 over f, which should make sense to you because, for example, right here, well, if 1 over si is 0, well, that means si is infinity. That means so equals f. Oh yeah, that's the case where if SO equals F, you get no image. Where the one that's up right over there. Okay, this is the one where 1 over SO is 0. Well, when does that happen? That's when SO is equal to infinity. That's your example with the sun, and that's why that would happen. So then, SI equals F. Okay, so you should have something like that. And then there was questions that said, well, hey, if you had a lens with, I don't know, a shorter focal length or a longer focal length. Well, let's take a look. So if this is smaller, so let's say you had a shorter focal length. So if the f over here is smaller, well, that means this whole piece is bigger. Okay, that whole piece is bigger, which means that whole piece, what did it represent? That represent the y-intercept. Well, that means your two intercepts are bigger. Well, that means if you have a smaller focal length, then b is bigger, which means you're going to get a graph that's going to look something like that. Okay, where again that was supposed to be with a straight line. But again, hopefully that makes sense. I would just recommend use the equation and make sense out of it. So hopefully that helps. Bye, kids.